Hello everyone, and welcome to today's session on merging arrays. In this presentation, we'll introduce the concept of merging arrays, explore different methods used across programming languages, and discuss performance considerations and best practices. By the end of the session, you'll understand what array merging entails, how to implement it in various languages, and how to optimize your approach for efficiency. Let's get started. Merging arrays means combining two or more arrays into a single array. This process can take several forms. You can simply concatenate arrays end to end. Alternatively, you might merge arrays based on specific conditions, such as performing a sorted merge. The purpose behind array merging is to simplify data management and facilitate operations on aggregated data sets. This operation is common when you need to consolidate data from different sources or prepare data for further processing. There are several scenarios where merging arrays is particularly useful. Data aggregation, when you have data from multiple sources that need to be combined. Distributed computations, when combining results from separate computational nodes. UI rendering, in cases where different datasets need to be integrated for display. Data preprocessing, for tasks such as sorting or analysis, merging arrays can streamline your data workflow. Understanding these use cases helps in deciding when array merging is the best approach for your application. There are various methods to merge arrays, depending on the programming language and the specific requirements. Built-in functions and methods. Many languages offer built-in methods. For example, in JavaScript, you can use the concat method or the spread operator. In Python, you might use the plus operator or itertools.chain. In Java, methods like system.arrayCopy or collections utilities are often used. Manual merging. This involves iteratively appending elements using loops, which can also allow for conditional merging. Specialized algorithms. For sorted arrays, the merge routine from merge sort is an efficient approach. These methods vary in ease of use and performance, so it's important to choose the one that best fits your needs. But we will understand the merge operation of two arrays in C++. So let's jump into the Visual Studio Code to understand it using code. I am into the Visual Studio Code. I am first going to create a function called mergeAraysConcatenate. In this method, I define parameters for two input arrays, ARR1 and ARR2, their respective sizes, size1 and size2, and a destination array, merged, where I will store the result. I then iterate through the first array, copying each element into the merged array. After that, I loop through the second array and copy its elements into merged starting at the index equal to size1. This effectively concatenates the two arrays into one. Next, I create a function called mergeSortedArays. In this function, I assume both input arrays are already sorted. I initialize three index variables, I to traverse the first array, j for the second array, and k for the merged array. I then enter a loop that continues as long as there are elements remaining in both arrays. At each iteration, I compare the current elements of the two arrays, I insert the smaller element into the merged array and increment the corresponding index. Once one of the arrays has been completely traversed, I copy any remaining elements from the other array into merged, ensuring the final array remains sorted. Then, I write a helper function called printArray. In this function, I loop through the given array and print each element followed by a space. This function allows me to display the contents of an array easily. Now, in the main function, I begin by defining two constant arrays, ARR1 and ARR2, with predetermined values. I calculate their sizes using the sizeOf operator to determine how many elements each contains. I also compute a constant called concatenated size as the sum of these two sizes, since this will be the total number of elements in the merged array. I then declare an array named concatenated with the size concatenated size and call the mergeAraysConcatenate function to merge ARR1 and ARR2 by simply concatenating them. After the merge, I print the resulting array using the printArray function. Following that, I declare another array called sortedMerged with the same size. I call the mergeSortedArays function to merge the two sorted arrays into one sorted array, and then I print this sorted merged array using the printArray function. Finally, I end the main function by returning 0, which indicates that the program has executed successfully. Now let's run it and you will notice that both method works and return merged array. This approach demonstrates two common methods of merging arrays, one by concatenation and the other by performing a sorted merge, providing practical examples of both techniques. Now let's go back to presentation. While merging arrays is a common operation, there are important performance considerations and potential pitfalls. Time complexity. Merging arrays is generally O(n), since you need to iterate over each element. However, if you perform repeated merging within loops, the cost can add up. Memory usage. Consider whether you are creating new arrays or modifying them in place. This decision impacts memory usage, especially with large datasets. Data integrity. Be cautious about handling duplicates and ensuring that the order of elements is maintained, especially in sorted merges. Language specifics. Some methods create shallow copies, so be aware of how nested arrays or objects are treated. These factors are crucial when optimizing your code for efficiency and scalability. To wrap up, merging arrays is a fundamental operation used across many programming languages. Different methods are available: built-in functions, manual merging, or specialized algorithms, each suited for different scenarios. When merging arrays, always consider performance impacts, especially with respect to time complexity and memory usage. Best practices include using built-in methods for readability and maintainability, testing edge cases such as merging empty arrays or arrays with non-uniform data types, evaluating your language's libraries to choose the most efficient merging strategy. By keeping these best practices in mind, you can ensure that your array merging operations are both effective and efficient. I am done with the session. If you have any question, feel free to drop your question in comment section. On this note, I am stopping over here. See you in the next session.